Do we live in an infinite number of universes? This may sound like a strange question, but for scientists, it's not so outlandish. Okay. In fact, some scientists believe this is a real possibility. This is the multiverse theory. Okay. And today, let's find out whether or not we live in an infinite number of universes. The word multiverse simply means multiple universes. But do we really have any evidence pointing towards the existence of other universes? Let's find out. Welcome to our channel, the place where future billionaires come to get inspired. Level 1, the local multiverse. We can start off with a multiverse that's a bit more tangible. This is a level 1 multiverse. It's a direct extension of our own universe. In other words, it's the idea that even though we can only see a finite portion of the universe, aka the observable universe, there's an infinite amount of space beyond that. And this infinite space contains everything that was here from the beginning, just very far away. Stars, galaxies, planets, black holes, and yes, even other life. It's quite literally an extension of our own universe. If you wanted to travel to this part of the multiverse, you would have to build a spaceship capable of traveling faster than the speed of light. And that's just not possible, according to the laws of physics. Assuming we did figure out how to achieve that, we would eventually reach the edge of our observable universe and then continue to travel into the unobservable part of the universe. We would come across all those other copies of Earth, copies of the Sun, and copies of the Milky Way. At some point, we would also run into a copy of ourselves. Maybe we would have become intergalactic travelers by then, and maybe we'd be hanging out on a beach on a planet made entirely of gold. Who knows? The point is, we would eventually come across a copy of Earth exactly like the one we left, except it would be very, very far away. Level 2, the multiverse of physical constants. Now, let's talk about something a little less tangible. According to level 2 of the multiverse theory, there are infinite other universes, each with their own set of physical constants. These physical constants include things like the gravitational constant and the masses of elementary particles. The thing is, it's these constants that allow for the formation of stars, planets, galaxies, and all that good stuff. Without them, we wouldn't exist, so they must be just right. However, according to this theory, it's purely by chance that the constants are such that life can exist. Each constant has a range within which life, as we know it, could theoretically exist. For example, if gravity was slightly stronger or weaker, life couldn't evolve on Earth. Or if the mass of protons were even slightly different, stars wouldn't produce enough energy to support life. Okay? And since the constants need to be just right for life to exist, okay, it's entirely possible that other universes have different constants, okay? And in those universes, life might not exist, or it might look completely different. So how do we test this theory? Well, first of all, scientists don't actually agree that this is a theory at all. Some say it's more of a philosophical view. Regardless, let's pretend it is a theory. How would we go about testing it? One way physicists have suggested is to look at the cosmic microwave background radiation. The cosmic microwave background is essentially the oldest light in the universe. If we look at the radiation coming from different parts of the sky, we should be able to see fluctuations caused by variations in the physical constants. Fortunately, we haven't been able to do that yet, but it's a promising avenue of research. Level 3, the many worlds interpretation. Do you remember the last time you had to make an important decision? Maybe you had to choose between 2 job offers, or maybe you had to decide where to spend your vacation. Well, according to level 3 of the multiverse theory, every time you make a decision, you split the universe into 2 separate pieces. In one piece, you choose option A, in the other, you choose option B eventually. These universes split again and again, creating countless copies of the universe, each slightly different from the others. This is known as the many worlds interpretation of quantum mechanics. Remember when we talked about those physical constants that make life possible? Well, according to this interpretation, those constants are constantly shifting, creating alternate universes where things are slightly different. Now, you might be wondering what the difference is between levels 2 and 3. And honestly, the difference isn't super clear. It all depends on what you think about quantum mechanics. Many scientists think that the many worlds interpretation is correct, while others think it's wrong. Okay, in either case, let's move on to level 4. Level 4, the ultimate ensemble. So we've talked about an infinite universe where everything is exactly the same. A universe where everything is slightly different. And we've talked about an infinite splitting of the universe based on decisions and quantum events. But level 4 of the multiverse theory takes things to another level. According to level 4, which is also known as the ultimate ensemble, every single universe that's mathematically possible actually exists. To understand what that means, consider all the atoms in the observable universe. Each atom can exist in many different states. The position, momentum, spin, and other properties of each atom can vary over a wide range. Because of this, there are an infinite number of possible configurations for the atoms in the observable universe. And according to the ultimate ensemble, all of those configurations exist in other universes. Theoretically, this means that in one universe, you made that job switch and became a millionaire. In another, you stayed where you were and won a Nobel Prize. And in yet another, you decided to become an astronaut and flew to Mars. The thing is, we can't really test this theory because it doesn't make any testable predictions. This is why many people regard the multiverse theory as unscientific. It's basically the idea that since we can't prove or disprove it, it must be true. But wait, there's more. Scientists have come up with a bunch of other reasons to support the multiverse theory. For example, there's the theory of eternal inflation. Eternal inflation is essentially the idea that the entire universe is inside a giant bubble. This bubble is constantly expanding, and new universes are being created inside it. We don't have any evidence for this theory, but it's a popular one among cosmologists. There's also the holographic principle. The holographic principle suggests that the information contained in a region of space is actually stored on the boundary of that region. Think of it like a hologram. We don't have any direct evidence for this principle, but it's an interesting idea that could potentially explain the nature of reality. And then there's string theory. String theory is a theoretical framework that attempts to unify all the forces of nature. It's also a mathematical framework that requires extra dimensions. Now, these extra dimensions can't exist within our universe, or at least we have no evidence for them existing here. However, string theorists have suggested that they could exist in other universes. So, that's pretty neat. Now, here's the thing. All of these theories are highly speculative, and they read mostly mathematical frameworks that attempt to describe the nature of reality. They're not exactly testable, which is why the multiverse theory is often regarded as unscientific. That said, it's still a fascinating idea that's worth exploring. At the end of the day, we can never be sure if there are other universes out there. But that hasn't stopped scientists from trying to understand the nature of reality. After all, that's what science is all about. It's trying to understand the world around us. Now, we didn't talk too much about the evidence for the multiverse theory, because there really isn't any strong evidence for it. But that doesn't mean scientists aren't looking for it. In fact, there are experiments being conducted all the time that could potentially detect signs of other universes. One of the most promising avenues of research is looking for fluctuations in the cosmic microwave background radiation. As we mentioned earlier, the cosmic microwave background is the oldest light in the universe, and it's possible that we could see fluctuations in it that could indicate the presence of other universes. Another way scientists are trying to detect other universes is by looking for changes in the vacuum expectation value of quantum fields. The vacuum expectation value is the average value of a quantum field in a given region of space. If we were to see a sudden change in the vacuum expectation value, it could be evidence that we've detected another universe. It's also possible that we could detect other universes by looking at gravitational waves. Gravitational waves are ripples in spacetime that can be caused by a variety of phenomena, such as the collision of black holes. If we were to detect a gravitational wave with an unusual signal, it could be evidence that it came from another universe. Now, it's important to note that none of these experiments have been successful so far, but scientists are continuing to look for signs of other universes. Do you think there are other universes out there? Let us know in the comments below. And if you want to learn more about the multiverse theory, we'll include some resources in the description. Thanks for watching, and we'll see you next time.